Hello again. We are continuing our discussion of exponents and exponential functions by talking about scientific notation. And this shows up not just in math, but in science as well, so it's kind of important to know. What is it? It's basically just a way of writing really, really big numbers and really, really small numbers without using all those zeros that might show up at the end. So for example, if I'm looking at the mass of the sun, it is that number there that I'm not even going to try to say. But that's all I know is it's a lot of zeros. And so here's how I fix it so I don't have to remember how many zeros to write. What I'm going to do is I'm going to take a decimal point and I'm going to put it after the first non-zero digit that I see as I read the digits from left to right. So that is the 1. I'm going to take a decimal point and put it after the 1, and that's going to make the number 1.989. I don't need to worry about all those zeros after that last 9 because once you're past the decimal point, once you're to the right of the decimal point, all those zeros aren't very meaningful. So I don't need to write them. Now what I'm going to do with that 1.989 is I'm going to see how many times I would have to multiply by 10 to get the decimal from where it is in 1.989 to where it should be in that actual big number. So I'm going to move it and move it and move it and move it, and that's the original number there. I had to move the decimal 30 places to get it to where it needs to go. So that's like taking 1.989 and moving the decimal 30 times is the same thing as multiplying by 10 30 times, so that's 10 to the 30. So that's how I write it, 1.989 times 10 to the 30. Okay, let's look at an example of a really small number. If I have a hydrogen atom, the mass of it is going to be that number there. Again, I'm not going to try and say that, but I am going to go through the same process. If I look through those digits from left to right, the first non-zero digit I see is that 1. So I'm going to put the decimal place, or the decimal point after it, creating the number 1.66. All right, now I just need to see how many times I would have to move the decimal to the left or divide by 10 to get the decimal where it needs to be in the actual number. So I'm counting and counting and counting, and it looks like it's 27 spaces to the left. So that means I would have to divide by 10 27 times in order to get the decimal to be where it should be in the actual number. And dividing by 10 to the 27 is the same thing as multiplying by 10 to the negative 27. So my number is 1.66 times 10 to the negative 27. What you'll find is when you have really small numbers, then the exponent of 10 is going to be negative, and when you have really big numbers, your exponent of 10 is going to be positive. So here's some more examples. 15,140 is 1.514 times 10 to the 4. 0.391 is 3.91 times 10 to the negative 1. 420 million is the same thing as 4.2 times 10 to the 8. 0.00054 is the same thing as 5.4 times 10 to the negative 4. 856.231 is the same thing as 8.56231 times 10 to the 2. And 9.839 is equal to 9.839 times 10 to the 0. And it's an exponent of 0 because I really didn't have to move the decimal at all. It was in the right place to begin with. So now let's look at what we would have to do if we were multiplying two numbers that were both in scientific notation, like 2.5 times 10 to the 8 times 3 times 10 to the 5th. Okay, well, what I'm going to do is I'm going to group those parts of those numbers together. I'm going to put the decimal parts together in one set of parentheses and the exponents of 10 together in another set of parentheses. So I've got 2.5 times 3 in one set and 10 to the 8 times 10 to the 5 in the other set. And I'll multiply them separately. So 2.5 times 3 is 7.5, and 10 to the 8 times 10 to the 5 is 10 to the 8 plus 5, which is 10 to the 13. Okay. And when you're multiplying, what you'll find is that decimal number it doesn't have the decimal in the right place. So you may have to adjust. And here's an example of that. If I have 7.1 times 10 to the 3rd, and I'm multiplying that by 4 times 10 to the 6, I'm still going to group the decimal numbers together and the powers of 10 together, and then I will multiply. 7.1 times 4 is 28.4. And 10 to the 3rd times 10 to the 6 is 10 to the 3 plus 6, which is 10 to the 9. But look at that 28.4. The decimal is supposed to be after the first non-zero digit, but it's not. So I need to move it so that it is at 2.84 instead of 28.4. What that means is instead of moving the decimal 9 places like I had to get it to the right place, now since I've moved it an additional place to the left, in order to get the actual number, I need to move it an additional place to the right. So I have to move that decimal 10 places, not just 9. So my answer to that question is actually 2.84 times 10 to the 10. Let's talk about dividing. So if I have 8.1 times 10 to the 9 and I divide that by 3 times 10 to the 4, I'm going to do the same thing. I'm going to group the decimal numbers together and the powers of 10 together. So I get 8.1 divided by 3, and that's being multiplied by 10 to the 9 divided by 10 to the 4. Okay. So and I'm going to divide each set of parentheses separately. Well, 8.1 divided by 3 is 2.7, and 10 to the 9 divided by 10 to the 4 is 10 to the 9 minus 4, which is 10 to the 5. And again, I may have to adjust. So if I have 1.8 times 10 to the 7 and I'm dividing that by 7.2 times 10 to the 2, grouping the decimals together, grouping the powers of 10 together, 1.8 divided by 7.2 is 0.25, and 10 to the 7 divided by 10 to the 2 is 10 to the 7 minus 2, which is 10 to the 5. But that decimal point in 0.25 is in the wrong place. The first non-zero digit is that 2, and the decimal point needs to be after the 2. So if I move it, it's going to be 2.5. Okay, but what that means is I would have to move the decimal one less place to get it to where it needs to be. It's already been moved to the right one place of those 5 places that I would have to move it. So I really only need to move it 4 more spaces, not 5. So my answer is 2.5 times 10 to the 4. All right, so there's a lot of information to absorb in this lesson. Please take your time to think about it. If you have any questions, please let me know, and I will see you tomorrow.